Hello. In this tutorial, we're going to introduce you to Abaqus CAE, get you familiarized with the interface of Abaqus, and give you a general idea of how to perform a basic finite element analysis in Abaqus. We're going to accomplish this using an example. We're going to simulate the loading of a barbell stand with a barbell, just like the ones you see in a gym. Now, barbells can be pretty heavy, so if you were designing a barbell stand, you want to make sure it's strong enough to bear the weight of the barbell. And one way to do that is to analyze it in Abaqus. On the monitor behind me, you see a 3D model of a barbell. Let's take a closer look at that. The setup consists of two stands holding up a barbell, each bearing an equal share of the weight. We're going to use the dimensions from this schematic. We'll be using SI units, where length is in meters. The stand is a solid block made of steel with a density of 7.8 grams per centimeter cube, a Young's modulus of 200 gigapascals, and a Poisson's ratio of 0.3. When performing finite element simulations, it is not necessary to model every single part of your simulation. Engineers often decide what needs to be part of a simulation and what doesn't, in order to save time and computational resources. We do not need both barbell stands in the analysis. We can just use one and assume it carries half the weight of the barbell. To simplify the simulation further, we don't model the barbell at all, but replace it with a force equal to its weight. Here you see a depiction of the barbell stand with loads and constraints applied. A force equal to half the weight of the barbell will be applied in the U-shaped clamp where the barbell will sit. The base of the barbell stand, which is normally in contact with the ground, will be fixed in space using an Ancaster boundary condition, meaning that it cannot translate along the X, Y, or Z axes, nor can it rotate about them. So let's go into Abaqus and give this a try.